Hi guys, welcome to highschoolmaths.co.uk. Today we're going to look at the 2018 National 5 Paper 1. So we're going to crack on with this. First question, we've got a little fractions question. So a few alternative ways to deal with this. I like to just make the fraction top heavy first rather than deal with mixed fractions. So 2 3s are 6, add on top 7, so we get 7/3, add 4/5. And when you're adding or subtracting fractions, then we need a common denominator. So if we look at the denominators, we get 3 and 5. The lowest common multiple of 3 and 5 is 15. So 15 for both fractions. The first fraction would multiply by 5. 3 times 5 is 15. 3 times 7 would be 21. That makes that a first equivalent fraction. Second fraction would multiply by 3. 5 times 3 is 15. 4 times 3 would be 12. So we've got our equivalent fractions and our common denominator now. We just have to add the top line. So we get 33 over 15, which then simplifies how many 15s fit into 33? Well, 2, with the remainder of 3 out of 15. Now, just be careful with the fraction part at the end here. If you end up with a mixed number, make sure your fraction fully simplifies. These are both in the 3 times table, so we get 2 and a fifth. You can also simplify at this stage if you wanted to as well. As long as you simplify, as long as your final answer is fully simplified, that's fine. Okay, question 2. Expand and simplify. Okay, so we've got 3x plus 1 in the first bracket, x minus 1 in the second, plus 2 bracket x squared minus 5, and we're going to multiply the brackets. So 3x times x is 3x squared, 3x times negative 1 is negative 3x, 1 times x is plus 1x, and 1 times negative 1 is negative 1. Multiplying this single bracket, we get plus 2x squared, and multiplying this bracket, 2 times negative 5 to give you the negative 10. Once we've done that, we're looking to collect like terms. So we have got a 3x squared here and a 2x squared here, both positives. So that gives a 5x squared. Funny looking x. We've got a negative 3x, a plus 1x, and no other x terms. So that gives us negative 2x, and a negative 1 and a negative 10 to make negative 11 for our final answer. Okay, question 3. System of equations, solve them. Simultaneous equations. So let's give us a little bit of space. 4x plus 5y equals negative 3, and 6x minus 2y. Oh, that's a wee bit squinty. Let's have another go at that. Okay, so 6x minus 2y equals 5. We'll call that equation 1 and equation 2. So if you look at the coefficients of the x's and the y's, there's no same coefficients. So we're going to multiply or scale the equations up. So I'm going to multiply the first one by 2 and the second one by 5. There's a variety of different ways to do this. So equation 1, if we're multiplying it by 2, we get 8x plus 10y equals negative 6. And the second one by 5, we get 30x minus 10y equals 25. We'll call that equation 3 and 4 since we've scaled them both up. Now we've got the 10y terms, which should cancel out if we perform the correct operation. The signs are different. And that means we're going to add them together. So we add 8 and 30 to give us 38x. 10 add on negative 10 cancels, and negative 6 add on 25 would give us 19. Okay, so x equals 19 over 38, and that's given us x equals a half or 0.5. I prefer to stick to fractions, but if you prefer decimals, 0.5 would be fine here. We then substitute that value in, so we're going to take that value up to one of our original equations. I'm liking the look of equation 1 a little bit more, so 4x plus 5y equals negative 3, and that's equation 1. We know the x value is a half, so it's 4 times a half plus 5y equals negative 3, and we've just got a straightforward linear equation. Half of 4 is 2, 2 plus 5y equals negative 3. 5y, take away 2 from both sides, and we get negative 5, and then y equals negative 1. Okay, so we've got two values, so we've solved that system of equations. We've got x equals half and y equals negative 1. Cool. Okay, question 4. Two vectors are given by, oh, I've chopped a little bit of the question off here. Let's bring that down a little bit. There we go. Now, we've got two vectors, u and u plus v. Find the vector v. Express your answer in component form. Okay, so if u is this one and u plus v is this one, then if we subtract them, that'll tell us vector v. Okay, so if we do u plus v, take away the vector u, then that gives us the vector v, which is what we're looking for. Okay, so that's what we're going to use. We're going to do this one, u plus v, take away this one. Okay, so 6, -4, and 3. Oh, weird brackets. Take away 1, 5, and 1. And we'll just do a component at a time. So x components, so 6 take away 1 is 5, -4 take away 5 is -9, and 3 take away 1 is 2. Okay, and that's our answer expressed in component form for v. We'll call that v equals v. Okay, question 5. Solve a quadratic equation. Okay, so we're just going to try and factorize this. It's already equal to 0, which is good, so it saves us any kind of rearranging. So x times x to give us the x squared. Looking like it's going to be 8 times 3 for the 24. So that would give us 8x and 3x here. We want a minus 11x from these two terms, so minus 8x there and minus 3x here. That should work out if we double check. X times x gives us x squared. At the end, -8 times -3 gives us the positive 24, and our combined terms in the middle, both being negative, give us the negative 11x. So we want to bring this equation down here and this one down here, set each one equal to 0, and then solve. So x equals 8 for the first one and x equals 3 for the second. Okay, question 6. What have we got here? All right, so we're looking at part of the graph of a cos bx is shown. State the values of a and b. Nice and easy. So a is your amplitude. The coefficient of the cos term here tells us the amplitude. The wave goes up to 5 and -5. It's not been shifted up or down. It's perfectly symmetrical height in terms of height above and below the x-axis. So the amplitude of the wave would be 5. It's the distance from the middle of the wave to the top. Okay, it's a cos wave. It starts at the top, goes down. We've got 1 repetition, 2 repetitions. So at first look, that almost could be 2 waves, but we have to notice that the graph only goes up to 180 degrees. B tells us how many waves fall in the period of 360 degrees. So in 360 degrees, we would have 4 waves because 1, 2 fit into 180. So if we double that up to 360, we're going to fit in 4 waves. Something to watch out for there. Okay, question 7, little straight line question. Taxis, distance travelled. So we've got the price, the cost in pounds is dependent on the distance travelled. Okay, that all makes sense. And distances in miles, it gives us 2 points. So here, point A represents a journey of 8 miles, which is the distance. So that's the x coordinate. 8 along and 14 up. B, 12 along and 20 up the y-axis, or the p-axis in this case. Okay, find the equation in terms of p and d. Give the equation in its simplest form. Okay, so I'll do the work in here. So we've got find the equation on the axis in terms of p and d. We've got 2 coordinates, so first thing I'm going to do is find the gradient. So we've got our y2 minus y1 over x2 minus x1. M equals 20 minus 14 over 12 minus 8, and that gives us 6 over 4, which simplifies as a fraction to 3 over 2. Again, I would keep my answer as a fraction rather than decimal. 1.5 would be fine, acceptable as an answer. Okay, so we're not given the y-intercept here. You can find the equation of the line using y equals mx plus c or y minus b equals mx minus a. I'm going to go for the latter, so y minus b equals m bracket x minus a. And we need an a and a b value, so I'm going to use this coordinate here as my a and b. I could use this one, but this is just lower numbers, so it's going to make things a little bit easier. And this is my gradient. So y minus 14 equals 3 over 2 bracket x minus 8. And I'm going to multiply both sides of the equation by 2 here to remove this fraction. So we get 2y minus 28 equals now just a 3 bracket x minus 8. 2y minus 28 equals 3x minus 24, and 2y equals 3x plus 28, so plus 4. And we can rearrange that so it's y on its own. So y equals, dividing all through by 2, 3 over 2x plus 2. Now, it's asking for the equation in line in terms of p and d. So we've got to look at the axis. The y-axis is p, that's the cost, is 3 over 2, or 1.5, d plus 2. So that's what we're looking for there. Wee bit awkward with the numbers there, but same routine as you would normally use for finding the equation of a straight line. Part B, then asks us to calculate the cost of a journey of 5 miles. Okay, so we had here, P equals, that's really annoying. Sorry, that should have been on silent, and it's not. P equals 3 over 2d plus 2. So we're saying here, we're going for a journey of 5 miles, so the distance is 5, so P equals 3 over 2 times 5. Again, that's just 1.5 times 5, which is 7.5 plus 2, which is 9.5, or £9.50 for the cost. Okay, question 8. Determine the nature of the roots of the function. So f of x equals 2x squared plus 4x plus 5. And nature of the roots. Okay, so for the nature of the roots, that's talking about discriminant. If we hear those words, we're looking to see if we have two real distinct roots, if we have two equal roots or no real roots. So let's go for a discriminant test. A, B, and C. And A is 2, B is 4, and C is 5. It's the coefficients of the x squared, the x and number term. So b squared minus 4ac equals 4 squared minus 4 times 2 times 5, and that equals 16 minus 20. So we end up with negative 4 as our final answer there. Now, is that right? Minus 16 minus 4 times 2 is 8, times 5 is 40, not 20, honestly. Let's try that again. So 16 minus 40, which is negative 24. Now, at that stage, we've determined that the discriminant is negative, so we have to make a statement. So b squared minus 4ac is less than 0, so no real roots. Okay, and that's all that we need to write at that stage. Question 9. The diagram below shows a decagon. Angle KLJ is 17. We've got that in diagram. AKL is a straight line. Okay, so this is a straight line. And what are we asked to find? The size of the shaded angle KJL. So looking for this angle here from K to J to L. All the information in the diagram. Let's find some angles. So 10-sided regular decagon here. 360 divided by 10 is going to be 36. That's nice and easy, that calculation. We've got isosceles triangles all the way around. So if this is 36 here, that leaves 144 or 72 degrees either side. Let's see, so this is 72. This one's also going to be 72, which will help us because this full turn here is 180 for a straight line, which is why we were given that information to begin with. So it's 144, that leaves 36 degrees for this angle. If the full angle is in the triangle, if we look at just the triangle KGL, this triangle should add up to 180. So if we do 36 add 17, that is 46, 53, and that leaves us with 127 degrees. Okay, so that means all three angles within that triangle add up to 180. So that's the missing angle we're looking for. Great, done. Triangle XYZ. XZ is 10, YZ is 8, cos Z is 1 over 8. Calculate length of XY. Okay, so I'm going to call this my X. It's about trigonometry, non-calculator trigonometry. Ooh. So calculate f of xy. We've got two sides, and we're told kind of indirectly the angle between. We're not told specifically that the angle for z. We're told the value of cos of z, but hopefully that'll help us. Now, given that we've got two sides and the angle in between, that kind of leads us to the cosine rule. So that a squared equals b squared plus c squared minus 2bc cos a. And if we label this correctly, we're looking for cos A to go at the angle we have information for. So the cos A should go at the Z. So this would be our A and our small a. We're also looking for the small a here. B would be this one, and C could be this one. Doesn't really make much of a difference. B and C are interchangeable. So let's crack on through this. So b squared plus c squared, so it's 8 squared plus 10 squared minus 2 times 8 times 10 times cos of a. Now a is z, so it's cos of z, and we're actually told cos of z here is an eighth, so it's just times an eighth. And that's where that information comes in. So a lot of people find that really tricky, and the fact that it's not giving you an angle, but it's giving you cos of the angle. But the cos of the angle is what you need for the formula. So cos a squared equals 64 plus 100 minus 2 times 8 times 10. Well, easiest way to deal with this, I'm going to take the eighth of 8, which is 1. So we just got 2 times 10, which is 20. Remember, multiplying you can do in any order. So a squared equals 164 minus 20, which is 144. If we square root that, we get 12 centimeters. So if you do it in the right order, the answer works out pretty nice. So it's all about just making sure you choose the easiest path. Question 11, rational denominator. We've got 9 over root 6. Okay, so we can simplify that any more than it already is. So we're going to start off by multiplying by root 6 on top and bottom. That's how we rationalize. That gives us 9 root 6 over 6. And then we have to look at the fraction. The whole number part here, we've got 9 and 6, both multiples of 3. So I'm going to divide here and here by 3 to get 3 root 6 over 2, and that's as far as we can simplify that. It has a rational denominator now. The 2 on the bottom is a rational number, so we are happy with that. Okay, given the cos of 60 equals 0.5, state the value of cos of 240. It's one of those questions that always trips people up. Now, it is only worth 1 mark, but if we think about our cos graph, so if we take a quick sketch, that's a horrible line. Let's try that again. So we take a quick sketch of, let's just use the straight line tool. There we go, that's a bit better. Of what a cos graph would look like. We've got something that goes and roughly like that. That's not particularly great, but I'll do. -1, 0, 90, 180, 270, and 360. So that's the graph of y equals cos x. This is what the question is basically asked. Do you understand what happens on the graph of cos x? So if we go to cos of 60, and we look at the symmetry here, 60 degrees are about here, and my diagram is not perfectly accurate, so it's not going to work perfectly, but if we take that up, it's saying that this value at 60 degrees is 0.5. So let's say if we drag that across here, that's 0.5. Now, it's saying state the value of cos 240. If we look at where cos 240 is, cos 240 is 30 degrees below here. So that's around about this point here. So we're looking to find, if I dot that across, that what is the value of cos 240? Okay, now this is all to do with the symmetry. 30 degrees below 90 was 60, and cos of 60 gives the question was 0.5. 30 degrees below 240 is going to be the same value, but the negative value because it's below the x-axis, so it's going to be negative 0.5. So when it asks us for the value of cos 240, then that's going to be negative 0.5. We could do the same thing for other points in the graph. If it asks us for cos of 300, then that would be 30 degrees above this line. So 300 would be here. That would also be 0.5. Because it's 30 degrees above, 30 degrees below, you can tell by the symmetry of the graph, if you look at it, that it's going to give you 0.5 as well. And there's lots of various questions they could ask for that. So it's just really knowing the graph and how the symmetry of the graph works. Okay, question 13. So what we've got here is diagram shows a triangular prism. Okay, big giant diagram. Got some coordinates here. 405 at the top, 2, 0, 0 for the coordinate E. Triangular prism, yep, okay, doesn't tell us what type of triangle it is. Coordinates of A, B, and C. Okay, let's see, diagonal so triangle prism. Okay, so write down the coordinates of B and C. So looking for B and C. So B along here. Let's maybe, there we go. So we're looking for this coordinate up here. See if I can squeeze that in. There we go. If we figure this out, this is 2 along to this point here, and then to the middle of the triangle is 4 along, so to the end of the triangle is going to be 6, but we're looking for B, so B is going to be 4 along as well, because it's in the same line, same distance along as this one, but the distance back along the y-axis is the full distance along here. And it tells us that in the diagram that DC is 8 units. So it's going to be a distance of 8 units back, and then it's going to be the same height as well as this point, so it's going to be 5 units vertically on the z-axis. It's also looking for us to find coordinate coordinate C. So let's have a look at C. So C is way along at the end, so we've got to go 2 along to get here, 4 along to get in this kind of middle line, if we trace that up. So it's going to be 6 along to get to the end part here. Okay, remember D and C are in the same line. It's just a perspective of the diagram that can make it look a bit like C is further along. 6 along, so this point is 6 along to get to D, but when we have to go 8 back to get to C. Now we've already reached C, so we don't need any vertical height, so the vertical travel distance is 0 units. So that's the 0 units up the z-axis. Okay, question 14, change the subject of the formula, y equals g root x plus h2x. And g root x plus h. So we're looking to gradually break this down until we get the x term on its own. So the first thing I'm going to do is get the g root x on its own by taking away a h from both sides. So we end up with y minus h equals g root x. And then I'm going to get the root x on its own. So I'm going to divide by g on both sides, the opposite of type multiplying by g. So we get y minus h divided by g equals root x. And the opposite, to get the x term finally on its own, not root x, to get the x term on its own, we want to do the opposite of square rooting, which is squaring. So we end up with y minus h over g, all squared. And make sure you're squaring the whole side, so it's got to go in a bracket, equals x. We can flip that if we want, but we've got this the subject on its own, so we've got the x on its own. You could write it as x equals, and then this on the right-hand side if you wanted, but that would be fine for your marks there. Okay. Remove the brackets and simplify a little indices question. So 2/3 p to the power 4, all squared. Okay, so same way you would normally deal with a power of a power when you're using your indices rules. You would square the first term, the first part of the term, the numerical part. So the coefficient here, if we is a fraction. So if we square a fraction, we're squaring the top, we're squaring the bottom. 2 squared is 4, 3 squared is 9, so we end up with 4 over 9. We then use our indices rules for a power of a power, which tells us to multiply. So 4 times 2, so we're going to end up with p to the power 8. Okay, and that's our final answer there. So you're getting 1 mark for the 4 over 9. That's a funny looking 9, actually looks a wee bit like a Q. Let's fix that. There we go, 4 over 9. And another mark for the p to the power 8. Okay, question 16. Sketch the graph of this, and kind of on your sketch, show clearly the points of intersection with the x-axis, the y-axis, and the coordinates of the turning point. Okay, 3 things going on here. So probably the y-intercept is the easiest to do, the point of intersection with the y-axis. So for the y-intercept, we know that the x value is going to be 0, always. So we take the original function, which is x minus 6 and x plus 4, and we replace the x with 0. So we get 0 minus 6 and 0 plus 4, which gives us negative 6 in the first bracket times 4 in the second bracket. Negative 6 times 4 is negative 24. So that gives us a coordinate 0 for the x coordinate and negative 24 for the y coordinate. So there's our y-intercept. X-intercept is where y equals 0. So if we take the original equation, y equals x minus 6 bracket x plus 4, and replace the y with 0. I'm going to put that at the end, so we get x minus 6 bracket x plus 4 equals 0. And that's already in factorized form, which is quite useful here because it means we don't need to do the factorization. So we just solve this. So x minus 6 equals 0 or x plus 4 equals 0. That gives us x equals 6 and x equals negative 4 for the roots. If we want to write them as coordinates, it's 6, 0. Remember, it's the y coordinate is 0 for these ones, and negative 4, 0. So that's just got our x-intercepts or our roots. Now, the turning point links in with the x-intercept. So the turning point is always halfway between the roots. Please excuse my messy writing. So if our roots are at 6 and negative 4, then our x-coordinate is going to be half of that. So if we add them together and divide by 2, that'll tell us where the turning point is. So 6 add negative 4 is 2, divided by 2 is 1. So our turning point is at when x equals 1. And how do we find the y-coordinate? We go back to this original equation. So y equals x minus 6 bracket x plus 4 again. Notice that we've used that every time. And this time we want to know what the y value is when x equals 1. So we do 1 minus 6 and 1 plus 4, replacing the x's, substituting the x equals 1 in. That gives us negative 5 in the first bracket and 5 in the second, which is negative 25 altogether. So we get a turning point of 1, negative 25, x, then y. And it wants us to show a quick sketch of all this information. So let's do that. And we are just looking at a sketch here, so nothing, something a bit better than that though. Let's try using this straight line tool again. Here, there we go. So rough sketch, x and the y-axis. Let's see, what coordinates have we got? So I'll move this a little bit up. So we've got 0, negative 24. Okay, so let's say that's there. Not perfectly to scale, but 0, negative 24 for a y-intercept. We've got 6, 0, so let's say 6 along, 0 up, and negative 4, 0, so not quite as far along, so negative 4, 0. Okay, and we've got 1, negative 25, so 1 along, negative 25, that's just a little bit further down, so 1, negative 25. And that's, you can kind of see the shape of the parabola of the quadratic here. Here's where you get to laugh at my not so good drawing here. So x and y axis. We've got to join these dots up. It's much easier with a pencil, but I'll try. And this is your turning point here. So it needs to go back up. Oh no, it's unshaky. I almost had it there. There we go. So the turning point needs to occur at the point you've labeled 1, negative 25. A lot of people will try and have the turning point here. Just be careful with that. The turning point, this is the minimum point on the graph. So that needs to look like the minimum turning point on the graph. Okay, so that's that question finished. Quite a difficult one, quite a difficult one for only 3 marks too, but a lot of important facts there that are really, really useful. Okay, 17, we've got a square base pyramid as shown in the diagram below, 6 by 6. The square base has a length of 6 centimeters. The volume is 138 cubic centimeters. Calculate the height of the pyramid. Okay, so the height of a pyramid is given in the formula sheet. As V equals a third times the area of the base times the height. So if the area of the base is square base, so it's a third times 36, 6 times 6, times the height, which we do not know, but we do know that the volume is 138. So if we substitute the volume in the left-hand side, we end up with this equation. And we can then just rearrange that to find h. We've got one unknown. So I would look for the best way to do it. It's a non-calculator paper. A third of 36 is 12. So 138 equals 12h. And then we're dividing 138 by 12. Okay, and if you're not confident doing that, set out a little division sum. 12, 1, 3, 8. So how many 12s fit into 1? 0, carry the 1. How many 12s fit into 13? Well, that would be 1 with the remainder of 1. How many 12s fit into 18? Well, that would be 1. We'll go into decimals here, so let's put 0.00. How many 12s? So we had, how many 12s in 18 was 1. Remainder 6. And how many 12s into 60 would be 5. So the height is 11.5. 0.5 centimeters. Okay. Question 18, express sine x, cos x, tan x in its simplest form. Okay, so sine x, cos x, tan x, we're looking at substitution for tan x. Tan x is, if you remember, sine x over cos x. So if we replace the sine x with the tan x with the sine x over cos x here, what you'll notice is that we end up with a cos x here and a cos x on top and a cos x on the bottom of the fraction. They're going to cancel each other out. One's a multiply by cos x, one's a divide. So we end up with just sine x bracket sine x, which is sine x times sine x is sine squared x. Okay. Question 19, express in completed square form. So we're going to take that. I'm not going to copy down because I'm a bit limited with the space here. So we've got our bracket squared. The x squared drops down to x because we were squaring the bracket. We have the coefficient. Negative 3 squared is 9, so we're going to take away 9 and carry the minus 81 down. We then tidy up the terms outside the bracket, so that's going to be minus 90. The big number there. Okay, so we've got our completed square form. Hence, state the equation of the axis of symmetry of the graph of the function that we were given to begin with. Now, the axis of symmetry, if you remember, the completed square form will tell us the turning point. So if we look back to this, the turning point would be 3 from the bracket. So the x coordinate would be 3 and the y coordinate would be negative 90. The axis of symmetry cuts straight through the x coordinate of the turning point. It's a vertical line. So the axis of symmetry is x equals 3. And that's why it's asking us to state, because really we didn't need to do much work in there to get from x minus 3 to x equals 3 for our axis of symmetry. The roots of the equation x squared minus 6x minus 81 can be expressed in the form d plus or minus d root e. Find algebraically values of d and e. Okay, so this is looking at the key part here really is the plus or minus. If you recognize that, that will be your quadratic formula. That's the only place in National 5 you'll see the plus or minus sign come into place. So we've got d plus or minus d root e. We want to use the quadratic formula, so that means we need a, b, and c values. So we've got a is 1, b is negative 6, and c is negative 81. So the quadratic formula again from the formula sheet, and there's that plus or minus all over 2a. And we're just going to play on through that until we get to the end. So negative b would be negative negative 6, double negative 6 would be plus 6 plus or minus square root of negative 6 squared minus 4 times 1 times, next space here, negative 81 all over 2 times 1. X equals 6 plus or minus square root of, so that would be 36. So 4 times 81 would be 162, 324. So it's going to be plus 324 all over 2. 6 plus or minus, that's going to be 360. That's actually quite a nice number over 2. And now what it's looking for us to do is try and simplify this. So it's rather than solve, because we've not got a calculator, we're going to try and simplify. So we get 6 plus or minus, and the square root of 360 is a surge. So we want to think of what times what gives us 360, and it's going to be 36 times 10 all over 2. Now, if we continue with that, that's 6 root 10 all over 2. And now what you'll notice is that each of the terms, each of the whole numbers are multiples of 2. So we can divide each of these by 2. We get 3 plus or minus 3 root 10 all over 1. Which we put in. If you're dividing by 1, that's just 3 plus or minus 3 root 10, which is what we were looking for. So that's in the form d plus or minus d root e. And you'll notice that the d terms are both the same, which is a kind of clue in the question that you should end up with these two values being the same for your final simplified answer. Quite a difficult question to, but you should be able to, As long as you establish that that plus or minus means you use the quadratic formula, you should be able to work your way through quite a bit of that question. This part is really tricky at the end though. Okay, so that was the 2018 National 5 Maths Paper 1. I hope you found that really useful. I am very sorry for the random pop-ups that appeared. Windows decided that it would pop my notifications back on just for the fun of it, but hopefully it weren't too distracting. If you did like the video, then please like it and share it, and if you want to check out more videos, remember to subscribe. Thanks for watching, and I'll catch you later.